All right. After that amazing session, now we've got Toast from the Hyperliquid global community, who will be talking more about how you can build apps on Hyperliquid, how you can build on the Hyper EVM, and a lot more cool instructions right there. So if you've ever done perp trading, you've ever heard of this amazing thing called Hyperliquid, today's your day to learn how you can build on it as a developer and go where users and liquidity both live together. Toast, are you ready? Over to you.
Thank you, man. All right. Well, thanks for coming to my thing. Just like with the introduction, I'm just a member of the community. I'm a builder on Hyperliquid. And, building on Hyperliquid is a little tricky. There are some gaps in the tooling and that sort of thing. And so I wanted to put this talk together specifically geared towards EVM builders because Hyperliquid runs an EVM chain. And on the surface, it looks like it would be very easy to just use. In my time, working in the Hyperliquid community, I've worked with the Hyperliquid Community Hackathon, and that was a very successful effort. We raised $250,000 and just from the community and our corporate sponsors, and we actually got some really good tooling built out of that hackathon effort. I also help out with HL Global, and I do some other apps and stuff like that. So. One thing to understand about Hyperliquid is that it's not really a single chain. It's sort of got two chains running in parallel. So there's sort of two different state machines running. And what you see in this diagram here is on the left-hand side is you've got the Hypurr core, which is the perps and spot markets, the order books that are sort of the core product of Hyperliquid. And then on the right-hand side of that diagram, you have the Hyper EVM. And they share a unified consensus that is called Hyper BFT. And that's where the states of both state machines are validated and sort of rolled up. I'm not an expert on cryptography and that sort of thing, so I couldn't tell you in details about how that works. But this is a good mental model of understanding how to build, especially if you want to interact with Hypercore. So you can deploy Solidity smart contracts on Hyper EVM, just like another EVM chain. But there are a lot of quirks, and in particular, the consensus is different. So there's some things that don't work, but for most purposes, it works pretty well out of the box. Recently, I finally succeeded in standing up a Reth node on the Hyper EVM testnet. And I actually wrote a guide with all my learnings and experiences. That guide is right here in this QR code, if anyone wants to take a look at it. NanoReth is a fork of Reth that is built for Hyperliquid. It has a lot of changes to make it kind of work, but we got it working, so that's great. I'll give you a second to scan if you want to see it. In my background, I'm sort of a quant data scientist, machine learning engineer, and so what I like to do is to index blockchain data. So if you like data like I do, you might want to run a non-validator node. This guide here is a good place to start. So I think the most important thing to understand about the Hyper EVM for EVM builders is the quote-unquote dual block architecture. This diagram here I've seen it a lot on the internet. It's actually a little bit misleading in terms of how it works because it kind of makes it look like the blocks are running in parallel. And that's not really the way that it works. But the basic idea is that there are two types of blocks on the Hyper EVM. There's small blocks, which are fast, and they've got a small maximum gas. I think it's 3 million. And then there's big blocks with 30 million, and those execute less frequently. So essentially what happens is you just have a sequential EVM block execution, and every second a small block is executed. And every 60th block is a big block. So you've got two mempools, and depending on the way that your user wallet is set, you'll be either sending your transaction to one mempool or the other. So essentially for most everyday transactions, if you're interacting with a smart contract, you'll probably want to use small blocks because you'll get a faster execution. But if you're deploying a smart contract, you want to use a big block, which will be a little slower, but you should have enough gas. to cover your smart contract execution. And so there's another tricky point about this, is that the block size and the mempool that you submit to is not set on the transaction request. It's actually set via Hypurr. So you actually need to initialize your Hypurr account and then set your EVM user type to big block or small block. And I have just a Python script here if you want to see, how you can do that for your user. But one gotcha is that you need to actually fund your Hypurr account to activate it before you can do this. Otherwise, you're stuck just with the default small blocks, which is just fine. But it's a tricky part that you need to, you need to be aware of when you're building here. So I'm going to talk about a lot of the new features that Hyperliquid sort of brings to the EVM. I sort of see Hyperliquid as like a applied EVM chain. So you have all these cool features on Hypurr, and you can interact with the Hypurr in your Solidity smart contracts. So I think one of the clearest and most straightforward tools is to actually just read the state of Hypurr into your smart contract. And for a DeFi chain like Hyperliquid, very often you want to look at things like asset prices. Maybe you want to look at balances, something like that on the order book side of the exchange. And that's where read precompiles come in. You get the state from the start, the time of the start of the block, whatever the state of the Hypurr is. That's the data that you're going to have in these read precompiles that you can read into your smart contract. There is a very helpful demo smart contract that is actually using one of our hackathon project's libraries. This is a very, very cool library. It's called Hypurr -EVM-lib. It's very useful, and it really filled a lot of gaps in tooling for Hypurr EVM. And so this smart contract will show you how to just read into your smart contract things like spot positions, spot prices, etc. from the order book. There's also a lot of extra tools around reading the state of perps markets, as well as other information that you might want to get from Hypurr. And read precompiles are very useful. Another really cool feature of Hyperliquid that unlocks a lot of different interesting products and permissionless capabilities is coin or token linking between the Hypurr and Hypurr EVM. So what this looks like is, whatever your same private key is for your EVM account, you can use for Hypurr. So you have one unified account across both state machines. And you effectively are able to bridge, quote unquote, between the two state machines. So you've got essentially two balances. You've got a balance on your ERC20 contract on the EVM side, and you've got a balance on Hypurr. When you link the account, you link a ERC20 contract that you've deployed to Hypurr. There's a system address on the EVM that you simply send your funds to, and those funds will appear in Hypurr, and then bridging back is similar. So as an example of the kind of thing that you can build, let's see if I can get this. I might actually show you. I don't know, is anyone here familiar with the NFT fungibility protocol called NFTX? Yeah, so this is essentially just a vault. You can put your NFT into it in exchange for one ERC20 token. So what I did on the testnet EVM is I deployed a fork of the NFTX v2 contract. And then I was able to deploy vaults and link the ERC20s to Hypurr. So it's risky. I don't know if I want to risk showing you this with our technical things. Okay. Yeah. Uh-huh. So basically, yeah, just like with NFTX, you can vault your NFTs. So I'm going to do that. It's really risky. I don't know if you... Classic. Take a moment to ponder the Hypurr EVM. So I've deployed a testnet NFT contract for the Hypurr NFTs. If anyone's familiar with Hypurr NFTs, they're very awesome. So this will fund me with one ERC20 token. And then I'm able to bridge right to Hypurr Core just by sending to the system address that was generated when I linked this to the Hypurr Core ticker. Keep in mind that Hyperliquid testnet is perfectly fine. It's not geo-blocked in the United States. So once you're on this side, you're in the spot order book of Hyperliquid. And you can go ahead and dump your NFT in USDC. So I was able to just sell $100 worth of my fractionalized NFT there. And then you can do whatever else you want. You can bridge it back. But this is just a simple demonstration of how you can take protocols that were developed on Ethereum mainnet and sort of leverage some of the features on Hyperliquid to do things like list your own coin on an exchange. Now, if we look at this, this is just a demo front end for that read precompile smart contract that I showed you guys. You can just call the EVM RPC and pull this balance out. I mean, this is trivial, but you can also get this balance into your smart contract for whatever logic you want to implement. So in this case, the token that I deployed on testnet Hypurr Core is token 1460. And then you're able to query the EVM RPC to call that function. This is what that looks like. So this precompile lib here, again, is an awesome hackathon project that won some of our prize money for our hackathon and abstracted this to make it very simple. It was a big pain to actually get this, but definitely want to use this tool. So this is what that looks like, and if you're curious about their implementation, it's all open source. Does anybody have any questions about any of this? I have a lot of content that I really can't get to in my time. I also just wanted to point out that we have some cool merch from HL Global. So if anybody wants a duffel bag, my friends over there have some for you that were left over from our Hyperliquid event. All right, I'm just going to talk briefly about our next item until we're out of time. But I do hope that you guys are getting an understanding of the way that Hyperliquid has leveraged the Ethereum world computer as a part of its stack. So Core Writer is, this is getting into the more advanced features, and Core Writer is a really tricky thing to do. So there's some pretty visible posts on Twitter about some of the difficulties of working with Core Writer, but this is effectively a way for you to fire any sort of execution over to the Hypercore side of Hyperliquid from your smart contract. The thing is that it's not a synchronous execution, and if something goes wrong on the order book side, on the perps side, or whatever your smart contract is doing, your smart contract won't revert. So for a Solidity developer, this is kind of a shift in the way that you need to think about your app design. And the order will send over to Hypercore, and it won't execute immediately. So you need to be careful about how you design your apps and your smart contracts to use Core Writer, but it is a way to actually to write and modify the state of Hypercore from your smart contract. On the EVM side of the chain, all the fees, priority and base fee, are all burned. It's just a detail for ETH nerds. It's Cancun, no blobs. And so again, getting back to tooling, we're given this chain that we love, with the tooling not quite working, and we, the community, are kind of trying to put it together and make it work a lot better. So Hypurr EVM lib had a lot to do with making Foundry work in particular. There's Hypurr EVM lib on the third bullet. This can help you mock up the precompiles and other Hyperliquid features for your testing. Also keep in mind that Hypurr EVM is still in the alpha stage, so it is a rough developer experience. In particular, the testnet is very difficult to work with. I personally am trying to work to improve it, but we don't have a block scanner, so it's really pretty tricky to work with. Mainnet EVM is in better shape. There's Etherscan runs a block scanner. The team supports it a lot more, but I've made it my personal mission to make the developer experience better on testnet. And this is just another point for designing your app. Just think about the processing order of blocks. And that's it. Thank you very much. This is a link to my Twitter account. I really appreciate you all coming. Hyperliquid.